Hello, welcome to this lecture. In today's lecture, I'm going to explain about permutation and combination. These are two techniques of counting technique. We are going to use permutation and combinations to count the number of outcomes in an event. In the previous video, I already explained about the reason why we need to use the counting techniques. So as a revision, the reason why we need to use counting techniques is if we want to calculate probabilities, we have to know the number of elements of an event and also the number of elements of the sample space. In the previous video, I already explained about addition rule and multiplication rule. I also gave examples. So let's discuss about permutations. So permutations are arrangement of objects. If we want to arrange objects and if order is very important, then we use permutations. As an example, if we want to arrange books in a shelf, we may arrange the books, for example, the statistics books in the first row and mathematics books in the second row. And arranging mathematics books in the first row and statistics books in the second row is different from arranging statistics in the first and mathematics in the second. And so there are formulas to calculate the number of permutations. The first formula is if we want to calculate the number of permutations of n distinct objects taken all together. It will be n factorial. We will consider example later. But if we want to arrange n objects in a specified order using r objects at a time, then we use the formula n factorial divided by n minus r factorial. The other formula is if we have objects which are K1 alike, K2 alike, K3 alike ways. For example, if we have statistics books which are the same type of books, and also mathematics books, the same type of books, and physics books, also the same type of books, so that we will use the formula n factorial divided by K1 factorial times K2 factorial times, and so on. Let's consider examples. Suppose we have letters A, B, C, D. How many permutations are there taking all the four? 4 permutation 4, which is 4 factorial divided by 4 minus 4 factorial. And this is 4 factorial divided by 0 factorial. By definition, 0 factorial is 1. So this will be 4 factorial, which is 4 times 3 times 2 times 1. And that will be 24. When we say factorial, it means if we have n number of observations, n factorial is n times n minus 1 times n minus 2 times n minus 3, and so on. The second question says, how many permutations are there? 2 letters at a time. For permutation 2, this is 4 factorial divided by 4 minus 2 factorial, which is 4 factorial divided by 2 factorial, and this will be 4 times 3 times 2 times 1 divided by 2 times 1, the 2 cancelled out, and it will be 12. Okay, this is the answer. The other example is hospital schedule. A hospital operating room needs to schedule 3 knee surgeries and 2 hip surgeries in a day. We denote a knee and hip surgeries as K and H, respectively. The number of possible sequences of 3 knees and 2 hip surgeries is as follows. We have knee, 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 hip, hip. So the ordering of like this is different from, let's say, for example, I can also do like this. K, H, K, K, H, or K, H, H, K, K, or K, K, H, H, K, or K, H, K, H, H. Such things. How many different permutations can we have? We are going to use the K-alike formula. The general definition for that, we said that n permutation R, it will be n factorial divided by K1 factorial times K2 factorial times up to Kn factorial. In our case, we have K1 is 3 and K2 is 2 hips. 2 plus 3 is 5. So then we use 5 factorial divided by 3 factorial, 2 factorial, which is 5 times 4 times 3 times 2 times 1 divided by 3 times 2 for the 3 factorial, and then again 2 times 1 for the 2 factorial. So these 2 cancel out, 3 cancel out, 4 divided by 2 is 2. So this will be 10. That's why we have 10 sequence are easily summarized as this expression. We can also use another example. Suppose we have the word correction. We are going to use the K1 alike, K2 alike formula. We have correction. So C, we have twice, R 2 times, and then O 2 times. The rest 1 times. If we add this word is 10, 10 factorial divided by 2 factorial, 2 factorial, 2 factorial times 1 factorial, 1 factorial, 1 factorial, 1 factorial. But 1 factorial is 1, so we can also leave out that. Then this is the expression. Now let's discuss about combination. Combination is a selection of objects without regard to order. So we don't care which comes first. As long as A and B are selected, we don't care if A is first and B is next, or B is first and A is next. And the formula for that is this one. We use this formula. N combination R, or N combination R, we can use either this expression or this expression, is given as n factorial divided by r factorial times n minus r factorial. Let's consider example. A bin of 15 manufactured parts contains 3 defective parts and 47 non-defective parts. A sample of 6 parts is selected from the 50 parts without replacement. How many different samples are there if size of 6 that contains exactly 2 defective parts are selected. We have n, which is 50. We have number of defective is 3. Number of non-defective is 47. If we want to select 6, which will be 50 combination 6, which is 50 factorial divided by 6 factorial and then 44 factorial. What if we want to select 2 defectives? So from the 3 defectives, we want to select 2. And from the non-defective, from the 47, we want to select 4 because we are going to select 6. So 2 plus 4 will be 6. And then we multiply. So in this expression, this will be 3 factorial divided by 2 factorial and 1 factorial because 3 minus 2 is 1. And then times 47 factorial divided by 4 factorial times 43 factorial. And that is 535,095 different ways. Another example can be among 15 clocks, there are 2 defectives. In how many ways can inspector choose 3 of the clocks for inspection so that number 1, there is no restriction. Number 2, none of the defective clocks is included. Number 3, only one of the defective clocks is included. And the last question is 2 of the defective clocks are included. We have N 15, R 3, number of defectives 2. So the first question it says without any restrictions. We are going to just select 3 out of 15, which is 15 combination 3, or I may use also this symbol 15 combination 3, and this is 15 factorial divided by 3 factorial. 15 minus 3 is 12 factorial. The answer for this is 455 ways. Number 2 said none of the defective clocks are included. Means from the 2 I'm going to select none, but from the 13 I'm going to select all the 3 defective. And this, you multiply this by this, that is 2 factorial divided by 2 minus 0 is 2 factorial times 13 factorial divided by 3 factorial. 13 minus 3 is 10 factorial. And the answer for this is 286 ways. Number 3 says one of the defective clocks is included. It means from the 2, 1 is included, whereas from the 13, 2, because the total clocks for inspection, it has to be 3. And so it will be 2 factorial divided by 1 factorial, 2 minus 1 is also 1 factorial, times 13 factorial divided by 2 factorial times 11 factorial. So the result will be 156 ways. The first one is 2 of the defective clocks are included. From the 2, 2 are included. And then from the 13, only 1 will be included because we need to have 3. And that will be 2 factorial divided by 2 factorial times 0 factorial times 13 factorial divided by 1 factorial, 12 factorial. So this will be 13 because this cancels out. These are additional examples. So yeah, this is all about permutations and combinations. If you have any question or suggestion, you are welcome. Please share and comment, and your inputs will help me to also design the next lectures nicely. So yeah, thank you very much. See you in the next video.